Hello friends, welcome again. So today we will discuss Idempotency, and it's like his high level design series. So if you are new, so I just said it's a high level design series. So today's topic is Idempotency, and let's just start and let's get started. So I already put notes in GitHub repository as well, and I will put a link in my description, and you can review that again. Quick review, right? Kind of notes. So I already prepared a notes for you. Idempotency. With a word, what is idempotency? Idempotency means executing the same request multiple times. Right? Executing same request multiple times. The final result as a executing it once, meaning whatever you are pressing button pay now, pay now, pay now, but you pressed 5 times, but only you should pay only one time, right? Without idempotency, money will be deducted 5 times. With idempotency, only one request will be like processed, four requests will be lost. Meaning you have like $1,000, right? And you clicked on pay now. Okay. Sure why. Okay. So let me change the mode. Um, tool, tool, and I think green is okay. Okay. So you got it right. Money maybe deducted 5 times, but with the redundancy, money will deduct only once. I think that tool was good. Let me go back. Hmm. Okay. So you have $1,000, or like you clicked on pay now like 5 times, right? So only okay, you paid pay now like $400, right? So only 100 will be deducted and 900 balance value remains, right? This is the ideal idempotency case. Okay. But without idempotency, suppose we don't have this concept, then what will gonna happen? 1,000, you clicked pay now once, balance remains 900, pay now twice, balance remain 800, click thrice, balance remains 700. Okay. So that's why idempotency is very, very important. Okay. Now, uh, let's see. A request message sent by the client to a server, place order, transfer money, book ticket, user ticket. For example, same example, right? Post payment, amount 100, request is 100, right? Server process operation, this is execution. Result outcome after execution, before balance was 1,000, okay, and after transferring $100, let me put, balance means 900. Whatever the example gave, right? This is the result. Now, a real time example, just like as suppose you order online pizza. Okay. So, placed order, intent becomes no. It's a usual thing, right? You don't know whether order was placed or not. You clicked again, again, right? Server got four requests. Request one, two, four, 3, 4, right? But the thing is, should we receive 4 pizzas? No, absolutely no. Okay. So only one pizza, not 4 pizza. So this is where idempotency helps. Okay. The same example here as well, right? Which I gave above. You have $1,000, money transfer 100, network timeout, server receives same request again without idempotency, right? You click like 3 times. Balance will go like this: 900, 800, 700. Okay. Money directed multiple times. Huge business loss. But with idempotency, only one request will be processed, other two will be ignored. Now let's see how to implement this idempotency design. Okay. Okay. So first of all, why? Why do duplicate requests happen? Let's see. So in what are the cases where we have duplicate cases? Okay. So let's see. So around 5 to 6 we have. First is network timeout. Your internet is slow. Client don't receive response. It means response lost. So this is the one case when we go for duplicate thing, right? Secondly, um, user user clicked multiple times. First of all, timeout meaning kind of internet slow. You uh, lost the response. Okay. Secondly, you clicked multiple times. Pay now, pay now, pay now. Multiple requests will created. Retry mechanism, just like as our latest tools, just like as here REST template, Kafka, MQs, Rabbit MQ. So whatever they do automatic like request failure, right? So automatic retries. Suppose you have here broker, Kafka broker, simple example, right? So consumer is expecting some data, right? So it is partition is allocated. Suppose something is wrong, right? In between data is failure, right? It will send data again, right? So this is the I'm talking about. This is the automatic behavior of our latest things, just like this test template or Kafka consumers. Okay, so they automatically retry the field calls. Then server crash. Server crash is request processed. Server crashes before sending response. Okay, before sending response, so client will retry. Duplicate request arrives. Okay, so these are the 4 principles. Now, uh, when duplicate request happens, now very important, how idempotency works. Okay, so how to implement or how it works. So let's see. So this is the main thing. We use idempotency key. Okay, we use idempotency key. Idempotency key is a unique identifier attached to every request. Okay, so client, server, okay, database. So client is sending request. Suppose payment request plus in the header we have idempotency key. Server sees the request, it will save key in database. Okay. Again, in case of network failure and response doesn't go through, so it will request again. But payment request, same key will go again, right? In that case, it will check. Do we have same key exist in database? Yes, exist. Ignore. If not exist, meaning first time, then process kind of thing. Okay. So this is the main funda, right? Idempotency is a unique identifier attached to every request. Now let's see. You may send $100 for the process, and we attached ES payment 1, 2, 3, 4, 5. Now, first payment pay 1 2 3 4 5, server checks the database, key exists, no, process payment, key store. Okay, this is the first step. Process payment, key store. So payment 1 2 3 4 5, return success. Okay, so this is a response, return success. Now, suppose in case of any kind of network failure or anything happened, we process second request. Now, same request, right? Same request arrives, same idempotency key will go. Whatever I explained earlier. Server checks the database, key exists, yes, ignore. Okay, only one payment. So this is the main concept. Okay, let's see the Spring Boot example. Simple. We have post payments, post meaning like post method slash payments. Simple. In the header, it sent payment 1 2 3 4 5. Right. Now, see request, check key. If exist, return old response. If no, process payment. Okay. Now, database will be like this. Create table, payment request, ID is number, idempotency key varchar, status, process or not, whatever. Right. So these are the important key members. This will be data, ID1, payment this, success. The same request comes again, payment 1 2 3 4 5, system sees the record already exists, no new payment. Okay. So this is one thing. Again, very, very important question. So first of all, interviewer may ask what is idempotency. After that, definitely he could ask, or he will ask what HTTP methods are idempotent. Okay, so only post is the method which is not idempotent. Rest all are idempotent. Let's discuss now. Get, we can read the same request. So we can file the same request user 100, read the patient 100 times. Server or same data will be get returned. Okay, if you update, suppose put request name Satish 100 times, it will update the same value again and again. Delete, same. Info deleted, it will delete, it will throw the same result, return the same result again and again. Delete. Okay. Only post will create the record every time. Okay. So get is read. Get is read, no change. Idempotent. Put is update. Okay. Idempotent. Every time same record we can update. Delete. Delete, delete is delete. Right. If one code is deleted, it will create the same result or will return deleted already. Idempotent. Post is the only method, right? If you send request 1, save. If you want request again, request 2, save again. Request 3, save again. Meaning it will create records and every post request have primary key, so that's why it will go away. So this is not idempotent. Okay. So this is the main like interview question you will face. Okay. Again, one more interview question you can ask. Can this post method become idempotent? We can say yes. Post method plus idempotency key can become a idempotent. However, post plus idempotent key can become idempotent. Okay. Into scenario. Design a payment system like Stripe. Okay. So just keep this in your mind. Okay. The cursor, my pen point is very important. Okay, here is my pen. So this is a very important thing. Payment must be idempotent because network failure and retries can create duplicate transactions. Okay, every payment should contain a idempotency key. The server stores the key in a database. Okay, just like as client high level I'm making right. Load balancer, suppose you have whatever five servers or like three servers, one server, two server, three server. So every time client will send idempotency key with your data. Okay, it will pass through your server. Then again, so it might have single database, it might have multiple database, it depends on our requirement. So we will store that key in the database. Okay, now if the key arrives again, the previous record response is returned instead of processing the payment again. The answer immediately demonstrates distributed knowledge. Okay, so whatever I designed here is the high level design of idempotency. Okay, now idempotency in Kafka, I gave little bit highlights over there as well. Suppose a consumer reads order created, then consumer crashed. Kafka sends message again without idempotency, inventory dues twice. Okay, which is bad. With idempotency, store processed event ID. Okay, just like as event ID 101, same event ID arrives, already processed, ignore. Exactly one processing strategy. Okay, so this may also be asked, what is exactly one's payment strategy? Okay, so this is the exactly one's payment strategy. Okay, so where is idempotency used? We already discussed, right? Credit cards, new pay payments, wallet payments, whatever, or in order placement, messagings, microservices, distributed systems. Okay. Hmm. Now, common mistakes. Let's see the common mistakes. So, thinking retries are enough. Okay. Thinking retries are enough. Retries solve availability. They do not solve duplicate processing. Mistake one is duplicate processing. Retry will create kind of duplicate processing using timestamp as idempotency key, which is wrong, which is mistake. Okay, two requests can have different timestamps. Bad idea. Now, no storing response. Good system stores idempotency key response status. So duplicate request get identically duplicate request gets identical response. Okay, so simple. At last, one line definition. Idempotency is a design principle. Idempotency is a design principle where executing the same operation multiple times produces the same final state as executing it once. Typically achieved using unique request identifier called idempotency key to prevent the duplicate processing in distributed systems. So this is the idempotency. Okay. So um, that's all. So if you have any question, you can ask me again, like in comment section. And if you're new, so you can join this channel. Like I'm putting high level design like concepts and making a series in very simple and understandable manner. Okay, and in very layman English as well. Okay, which means like why I'm doing this to make you people understand clearly. And if you face any sort of questions in your interview, then you will have better idea how to demonstrate that. Okay, so I'm closing the video now, and in the like starting I mentioned, I already created the notes as well. Okay, so I will put the GitHub comment in the video description as well. Okay, and you can go through all the notes in my GitHub channel. You will find all the notes there as well. Okay, so for now, thank you so much. And if you're new, subscribe the channel then. Thanks. Bye.